In the previous session, we looked at linear equations in one variable. Now let's look at linear equations in two variables. So a linear equation in two variables is often written as y is equal to mx plus c, where m is the slope of the line, c is the y-intercept. So here m tells us how steep the line is, and c tells us where the line crosses the y-axis. M and C are parameters. Once chosen, they remain fixed for a given line, while X varies and accordingly Y also varies. This form, that is Y is equal to mx plus C, is also called the slope-intercept form, since we can figure out the slope and the y-intercept by just looking at the equation. Now, the graph of a linear equation in two variables is a straight line in the Cartesian plane. All this we have seen when we were looking at graphs of linear equations, except the fact that y is equal to mx plus c is called the slope-intercept. Now, we have also seen that when m equal to 0, c equal to 0, what is the graph? So, here, if we substitute these values in the equation y is equal to mx plus c, we get y is equal to 0x plus 0, which gives us y is equal to 0. So for every value of x, y values remain 0. Hence the graph of y is equal to 0 coincides with the x-axis. When m is equal to 0 and c is some other number other than 0, for example, let's say c is equal to 3. Since m is equal to 0, the slope of the line is 0. So the line is horizontal. And since c is equal to 3, the line crosses the y-axis at y equal to 3, and which means it is parallel to x-axis. M is greater than 0, c is equal to 0. It is a line with a positive slope, that is going upwards from left to right, intersecting the y-axis at y is equal to 0, or we can say passing through the origin. When m is less than 0 and c is equal to 0, it is a line with a negative slope going downwards from left to right, intersecting the y-axis at y is equal to 0, or we can say passing through the origin. Now remember, we cannot use y is equal to mx plus c, that is a slope-intercept form, to represent a vertical line. Why? Now, the slope of a line is given by the ratio rise by run, where rise is change in y direction, so up or down, whereas run is change in x direction, that is left or right. So change in y direction means change in y, change in x direction means change in x. And usually we represent change in y or change in x using delta notation. So this can be written as delta y by delta x. And when it is a vertical line and we take 2 points on that line, there is a change in y, but there is no change in x, which means we are ending up dividing by 0. And dividing by 0 is not allowed. So the slope is undefined for vertical lines. So which means that y is equal to mx plus c cannot be used to represent a vertical line. So let us take the equation f of x equal to 2x plus 3, or y is equal to 2x plus 3. Taking some points x and evaluating y, we draw this graph. Now let's choose a point on this line and another point. You can pick any arbitrary point. Let's start from C and go up to parallel to the x-axis along D. And let's draw from that point to D a line. The vertical line is called the rise and this is called the run. So rise by run defines the slope of this line. So if we keep moving it, you can, that's why I said you can choose any arbitrary 2 points. So the intersection point would be E of these two line segments. So we have the slope of a line is given by the ratio rise by run. Now let's draw a vertical line. So let's take a point on x-axis and let's draw a line perpendicular to x-axis through G. And let's take another point F. Here you will notice rise is there. It is rising from F to G. But there is no run. So here in case of 2x plus 3, slope is equal to m, which is equal to rise by run, which is equal to 2. And in case of the vertical line, m is equal to rise by run, which is equal to 3.09 divided by 0. So you see, it doesn't matter where I take this point. So it is undefined because of this division by 0. So that was linear equation in two variables, part 1. That's it for now.